Welcome to Cpp.chat, a conceptual look at what's going on in the world of C++, chatting with guests from the community. But before we chrome in on this week's or month's or maybe year's guest, John has an important public service announcement.
Thank you very much, Phil. Past performance does not guarantee future results. You should not rely on past performance as a guarantee of future investment performance. Unit values and investment results will fluctuate. Investors are cautioned that data based on less than 5 years' experience may not be sufficient to establish a track record on which investment decisions can be made. All right. Thank you, everybody, for joining us. It has been a while, hasn't it? But it feels good to be back. Our guest is someone who has fallen off the radar, but is now, we're dragging him back into the spotlight. Christopher Davella is a software engineer working on Chrome OS at Google. So you're working on Chrome OS, which is not a Google product. I'm sorry, which is the Google. Well, I'm going to let you explain it because I'm confused about it. But you're working on Clang, right? And also we're going to talk about concepts because that's what I want to get into too. I'm sorry, I blew that completely, Chris. I apologize to you.
So I think the first thing to say is that although for Google, everything I say on here is my own opinions, and everything I say is not representative. So anything I say is not representative of a Google policy or position.
You're not an official Google spokesperson?
Apparently not. As I just said,
yeah, right. I understand.
And unlike John's, that was a real disclaimer.
Yes, that was a real disclaimer, unlike mine. Yeah.
What was I going to say? Right. So I don't work on Chrome OS specifically. I work on the Chrome OS toolchain, which is slightly removed. It's essentially, the goal of my team is to give people who do work on Chrome OS and build software for Chrome OS a robust and high quality toolchain. So that's very much that's very much involved with LLVM. Which is actually how I contributed my first Clang patches, and I've managed to also get a bit of LLVM, a bit of other, just touch on other LLVM projects, libc++ being one of them.
So, I have a history question, which is that my guess is, and that's why I'm asking the question, that at one point, sometime in the past, Chrome was GCC. Is that the case? Did it make a switch at some point to Clang, or was it always on Clang?
That I can't really tell you, not because of any particular reason other than I simply don't know. I think there's been a transition period, but that is about as much as I can say off the top of my head.
But now it's fully all about the Clang and LLVM.
It's not 100% LLVM yet, but it's very close.
Oh, I see. Okay. All right.
There's still one or two things that need a bit of attention.
Okay. So by that, you're saying there's still some things that are still on GCC?
Not GCC specifically, but I believe related to that toolchain.
I see. Okay. All right. All right.
Yeah. I've had to actually look into the GCC stuff and play with that for stuff that's not been committed, but just to get a bit of a better understanding. But that's about as much as I've touched on that side of things at the moment. So
this is one thing that I've kind of wondered about, and I'm not I'm not certain you're really the authority on that, but I had seen Clang get better and better adoption in lots and lots of places, and I'm wondering now if it's in a situation where there's kind of I don't know what to say. The GCC guys are not standing still either. And so I don't know if we're going to see a situation where at one point I honestly thought that Clang was going to eat the world. And now I'm wondering if, no, Clang is just getting to a size that makes sense for it, a market share that makes sense for it, and it's going to kind of stabilize. But I don't know. Yeah. I haven't really looked at this in recent years. But I know as I say, GCC is not standing still. They're pushing hard, and they're doing a great job of tracking the standard, which at this point is pretty challenging because the standards committee is running on all gears, right?
Right. Yes. We'll be touching on that, I think, at least once or twice later on. But yeah, I don't really have any. I haven't even observed what you've just commented on, simply because I've been looking for it. But I think my personal opinion here is that having GCC and Clang being neck and neck for fighting for market share, rather than having one that's sort of got majority market share, is a really good thing for both compilers, because it means that they've both got to stay at the top of their game, and neither of them will. If that's the case, then neither of them can really afford to sort of get complacent.
Yeah,
and
exactly.
I think that competitiveness just helps prevent complacency.
Yeah, I'm not sure if it's good for both compilers, but it's certainly good for the community.
Right. Yes.
And this is one of the things that I was always a little bit, I don't know how to quantify. I mean, it wasn't I didn't cry myself to sleep, but back when I was a full-time software engineer, actually writing code as opposed to just talking about code, I was never in a situation where I could have two compilers. There was always something so specific about, most of the time I was a Mac programmer. And so a lot of times, there weren't as many varieties, and sometimes some of the natures of what we were doing, it was like, no, this is the compiler you're going to use, and there's only one. And the idea that you could just to test it, which is what I'd really like to do, is I'd like to run this with another compiler. And even if for whatever reason that's not the shipping compiler, I want the warnings, I want the error messages, I want to know what its opinion of my code is. And that's something that you can do better now, I think, than you could in the past. In fact, I think tooling in general is so much better than it used to be, that I look back and think about the things we do and then realize all the things that we have now for tooling. It's really great. We're in a wonderful time from that point of view.
Right. Yeah, I genuinely think that, even a decade ago, the tooling wasn't as quite. We're quite blessed here in 2021 with all the tools we've got. Yeah.
So speaking of tools, although I'm not sure how much of a tool this is as much as a library, but one of the things that we wanted to talk about was libc++, which is the library for Clang LLVM, and the work you've done on it, because you've just recently hit kind of a milestone, I guess, right?
Yeah. So over the past, I guess, there's a little bit beforehand that they got committed in 2020, but the majority of the work happened over the past, I guess, 4 months. We've been able to get all of the concepts library committed and into main, and that means that it'll be shipping in modulo bugs. Although I don't know if there's anything. I know there may be one or two things that have the capacity for bugs. I don't expect them to have bugs, but I was going to say there's nothing that has the capacity, because it's just copy paste from the standard. There's a few things that's not the case. Anyway, it should be shipping, all going well, in LLVM 13, which I believe it has its release date set for September. But you can already try this out on Compiler Explorer, and you can, if you want to build LLVM, you can do that, or you can pull it from the nightly builds if you're running an apt-based version of Linux. I don't know about Windows. I've had a few questions about that, but I'm not sure how the Windows releases, how frequently they're done.
Okay, so I've got a lot of questions because I'm naive about all this stuff. So what you've done is you've talked about making the library support for concepts. Obviously, that depends on language support, which means we're talking 20 only, right?
Yeah.
Yeah. So, but on the other hand, if I'm, how do I say this? Suppose I am using the latest Clang, and we're not shipping this yet because you said September is what we're looking at. But I mean, are we going to have a situation where I'm not yet using 20? I'm still using 17, but I still want the latest compiler for the optimizations and all the tools and things like that.
Sure.
So am I going to use are there a bunch of if-defs is what I'm trying to say. Are there a bunch of if-defs in the library headers so that if I'm not using 20, I'm using the same libraries, or do I pull different headers? How is this going to work for me?
Right now, the concepts library is shipping as just the concepts header. Nothing is using it in nothing else in the standard library is using concepts. So there's no if-defs that. So for example, vector doesn't take advantage of concept because and I don't know. There's certainly no roadmap that I'm aware of. I don't know if we'll ever have plans to have if-defs for spin versus concepts because that may or may not hurt readability in some cases. So that'll probably be something that'll be explored long after we get through the ranges component of libraryification. I think that I may have misinterpreted the question there. So is that what you were going for?
Well, I was just wondering if I'm looking at the headers, am I going to see a bunch of if-defs to if-def out all the concept stuff or?
Oh, right. Yes. So if you, I think you can still include the concepts header in a C++17 program, for example, but it would be as if the file was empty. So the file exists, you can include it, but it's not going to do anything for you.
So I was thinking about algorithms that use concepts. Is that not there? Are the algorithms decorated with concepts, the ones in the library?
So the stud algorithms, which have been there since C++98, they haven't been touched at all, and the ranges algorithms, they haven't been added yet.
I see.
At the moment, we've only got the concepts that are in the concepts header, but there's also extra. So there's basically 3 concepts libraries in C++20. There's the concepts library. That's where you find things like copy constructible from, assignable from, what am I thinking of? Regular, those sorts of things. Mm-hmm. And then you've got the iterators library, which has its own concepts such as input iterator, forward iterator, indirectly copyable. And they're all focused on iterators. Those are in the process of being reviewed at the moment. And then you have the ranges concepts, which are things like forward range, view, input range, and similar things. Those are also in the process of being added. And once all that machinery is added, then we'll start thinking about the algorithms section. But that's all still very much in flight, and there's nothing that a user could pull today and start using, say, std ranges find. That's not possible at the moment. I
see. Well, so that was one of the things that I had assumed, that with iterators are an obvious thing to have for concepts, and I assumed that the standard library algorithms were updated for that. But you're saying that's...
So there's now actually 2 versions of each algorithm. There's the standard. There's the ones that are from C++98. They, for backwards compatibility reasons, couldn't be updated because the iterator concepts have changed from C++17 to C++20. That's why if you go to CPP reference, for example, you'll see that the named requirements have legacy input iterator, legacy forward iterator. It's referring to the things that are from C++98 through to C++17. And then we have the concept, input iterator, forward iterator, and so on. Those are the new definitions. And so they're slightly different. And so all the container iterators that we're used to from the standard library still work. But for example, the legacy input iterator expects that the iterator is copyable, but the new input iterator does not assume copyability. It only requires movability. And so if you were to try and feed a move-only iterator into, say, std find, and it did a copy somewhere, then it's suddenly going to break. But we can't go and change that algorithm to require the new input iterator concept, because that means that anyone who that means that it may actually break some code. And there's, I think, Titus Winters has done a talk or 2 on this, where he talks about if you have a concept as a part of your interface and you change it in either direction, you weaken the concept or you strengthen the concept, it's going to break someone somewhere. And so the workaround for that was we have now got a std ranges set of algorithms that require all the new stuff, all the new concepts, and they all work in harmony with that.
Yeah, right. That's an interesting thing about concepts, is that once you define that, you've defined that, and there is no modification of that without breaking code. And that's a little bit scary, although I think in some ways we should treat the standard more like that anyway. I think we mentioned earlier the standards, the committee's cranking out a lot of standard And sometimes I wonder if we aren't paying quite enough attention to quality issues on that. I mean, it's great. We've all been anxious about getting features, and that's terrific. I'm glad there's that appetite for that. But if the quality goes down, we live with that forever, and that's really annoying.
I think that the quality is still the bar for getting things in the standard is still very high, and I think that the committee is doing a good job of working out its priorities and what do we want to focus on. I haven't put as much attention into the committee over the past year and a bit because of everything that's been going on over the past year and a bit. But I do think that because I'm an individual member of the committee, I have my disagreement. I disagree with certain things that happen, but that's the case for everyone on the committee when it comes to direction. But I think overall, in general, the idea of ranking priorities is still pretty on track, and there's a good job that's going on there. Phil, do you have any thoughts on that?
I was just thinking that the whole idea of using all of the concepts for particularly the algorithms was one of the things that really held back C++11. When we got to the point we realised we need to take what we had of concepts out then, along with all of the uses of them that have been baked in through the rest of the standard. That turned out to be quite a big job. And was, not the only thing, but definitely one of the things that they did hold us back and made us a little bit more conservative about how we put concepts in again now. So I'm glad that it's been sort of taken a step at a time. Hopefully to avoid some of those quality issues that we're all worried about.
Well, I think the concepts that got in is a little less ambitious than the original concepts. I mean, one of the things that the idea with the original concepts is that the compiler could actually check and guarantee that algorithms were not, in fact, anticipating. There was no use that exceeded the concept. In other words, if you're writing a generic algorithm and you had some type, then you could use that type only as defined as a concept. And I don't think we have that checking yet.
No, we don't have that checking in the standard. I don't know if the standard will ever adopt that kind of separate checking. I would like to see there be assuming we don't adopt it in the standard, and I'm thoroughly convinced that it won't happen. I would like to see the compilers add a separate flag, like F, for example, with Clang and probably GCC, because their flags are very similar. F enables separate checking or something, or F separate checking. That brings this feature in, because it is a very useful thing to have if you've got if you understand how to use it. And I think that it would be a boon to programmers to have this sort of ability for checking that their functions do indeed behave as they're advertising.
Is this something that compilers can do? I mean, my understanding was the reason that it wasn't part of the feature is because, given the syntax of what we're doing, it's not tractable to do that. Maybe I was wrong about that.
I don't know the full history of the original concept specification from C++OX, but one of the problems with separate checking in a language that's supported completely unconstrained templates for 20, 30 years. Is that how long templates have been around for? Something like that.
It was predated. I mean, templates existed before the 98 standard. Although I remember when I started programming, which was before the 98 standard, I was explicitly told by more experienced people said, stay away from exceptions and stay away from templates, because those things are problematic. But everything else is great.
That's how opinions have changed over the years. But yeah, one of the key problems is that you've got this constrained function that says, for example, it's using input iterator, and then it goes to call an unconstrained function. Well, can we do that? Because it's completely unconstrained. What guarantees are on that you've said input iterator, but now this thing is completely unconstrained.
Right.
Is that possible? And is it possible to do that? And I don't have an answer for that because I'm not a compiler developer. I dabble with the Clang compiler, but I can't give you a concrete answer on that, and I'm not a core expert. Far from it. So that's one of the reasons why we can't adopt it. There's also the specification thing, which I think goes to, I guess, John, you're alluding to concept maps, which is one of the things that was dropped from the new design.
Yep.
And so I don't really understand much about them because I haven't looked into them very much. But I think for a lot of the things, a lot of the concepts that we have, we could get some element of separate checking done. And for the ones, at least for the standard concepts where we can't do that, directly, we can add sort of a library language interface that where the compiler knows, okay, this particular concept, such as constructible, which uses the constructible type trait, that maps this thing, and we can work from there. Again, I haven't done a lot of research into this, so this is me sort of thinking about how I would do it from the sideline perspective. If my plate ever clears up and I get a time to work on this, then I'd be in a better position to say, yes, this is possible, or no, absolutely not.
One of the things the tools can do that the language can't is the tools can kind of give a best effort. In other words, if the compiler is checking and sees you've called some function, it doesn't know anything about that function. It can just say, it could even give you a warning and say, you're calling this function and we can't verify. Or it could say, no, we only flag you when we do something that we know is incorrect. In other words, here's this forward iterator and you've done minus on it, and we see that, and there's no ambiguity here that's outside what the concept supports, and that's and that would be useful, right? Mm-hmm. But the standard can't very well say, well, a diagnostic is required in some cases. That's just not the way the standard's going to work.
Well, the standard can and does do that. For example, there are a bunch of semantic requirements on all concepts. Just because, so you've got the concept of quality comparable, for example, and basically what a quality comparable means is that you have type 1, type 2, and they instance 1, instance 2. If that returns true, then the opposite has to be true as well, and so it's got to be symmetric. And then you also need to have the not equal operator, and that needs to be exactly opposite to what the equal to operator is. So if you're not using C++20, then it essentially needs to return not A equals B. And if that is not the case, if you have your not equal to operator return the same thing as the equal to operator, then what the standard says is that this is not a valid C++ program, but because of the amount of heroic effort to actually computing whether or not this is a valid program, we're not going to impose that the compiler issue a diagnostic. So
right,
I
completely understand that. I'm saying, there's a lot of situations where we say, this is a situation where the diagnostic's not required. But the whole point of checking would be that a diagnostic, that it would be verifiable to you, and it will tell you when it doesn't do this. And that's what I'm saying is the standards committee is not going to say the compiler is required to warn you about this unless it's hard, and then the compiler doesn't have to do that. That's not the way that the committee's not going to do that. I do understand that there's countless examples of situations where the standards very clearly says, if you do this, it's undefined behavior. And by the way, the compiler is under no obligation to tell you that you're doing this. And that's the correct thing to do. That's exactly right. Yeah.
My other podcast is called No Diagnostic Required.
That's true. Yes. We've never talked about that. Can we put this on let's put this on hold for just a second, Chris, and let's talk about that Phil is undermining this podcast by making another podcast.
Well, it's a different type of podcast.
Is it you or you and Anastasia together, or how's this?
Yeah, it's the two of us together.
Yeah.
We take sort of topics each and have a bit of a discussion about them.
Yeah.
But it's really just community news and throw in a bit of JetBrains news as well.
Right. Yeah, that's terrific. And we have another podcast that we also haven't mentioned, and that is the NVIDIA guys. I think Connor and Bryce are doing one. I wish I could tell you the name. It's something like algorithms plus data equals programs, something like that. Some catchy name. Once we got Cpp.chat, we took all the good names. After that, it's got to be down here. Although I will say, No Diagnostic Retired is kind of clever. I kind of like that one. That's kind of cool. So anyway, and this is there's lots and lots of C++ programmers in the world. None of them have been commuting in the last year, but they are going to start commuting again. And when they start commuting again, they'll want to listen to podcasts on their commutes. And I think that having a lot of people generating good audio content is great. So anyway, sorry, didn't mean to derail the whole conversation, but when that came up, I did want, because it's been so long. There's so much news that has happened. And we've been quiet on the microphones. So anyway, where were we talking about? We were talking about diagnostics required. We're talking about checking on concepts. That's not in. That was part of the original goal, and I think that was part of what was able to get this version of concepts, which at one time was actually called Concepts Lite, to compare it with classic concepts. I guess I don't know if there's another name for that, but we've gotten that. It's in now in 20, and library support is in libc++, the Clang library, and that's terrific. So one of the things that I am curious about is what kind of adoption we're going to see. I mean, we've talked about how cool, and for somebody like me who's interested in algorithms and interested in the STL, this is such an obvious thing. It's clearly been something we've wanted for a long time. I remember before 11 shipped, we were, I talked about this with Alex, and how much this would have helped him in developing the STL. It would have made so much stuff easier to understand, easier to communicate, and but have we seen anybody actually using it? I mean, what are we seeing? What are people going to do with it? What's the first? Because right now, if you do what Ranges did, what Eric did with the Ranges library, if you said, hey, I've written this whole new library and it depends on concepts in order to make it easy to understand and easier to validate as a user. But of course, that means that the only people using it are people who are using C++20, which at this point is not a lot of people. That's, when are we going to see this? And I'm not saying you're the authority on that, but if you have any thoughts on it, or if you've seen anybody, is there somebody developing a library like this?
So that's a really interesting question. I definitely am not the authority on this. I think that the adoption is going to happen progressively over time, because it's going to, provided people are not interested in supporting backwards compatibility with C++17 or before, adoption. That's one of the things that is that it really hinges on. You've either got to have some sort of macro-based system to support concepts and SFINAE, or you've got to have, or you've got to make a decision. I want to have backwards compatibility, and so therefore I'm going to stick with SFINAE, or I'm not going to care about backwards compatibility before C++20. C++20 is the hard stop, and I'm going to do backwards compatibility up to C++20, but anything before that just doesn't exist to me, and I'm going to use concepts. Those are your three real options, and I don't really know. I don't really have a good idea of what people are going to want to do, but I do think that the quality of diagnostics that concepts issue from the compiler's perspective is going to have a fair say in that.
Well, I mean, yeah, the diagnostics is great, but just to be able to write code, I mean, SFINAE is just not pretty, and and it's got to be so much nicer I mean, even const expr if would clean up spinne so much, making the code so much easier to understand, so much easier to write, and then we can take that into concept. So I'm
Well, actually, that's a good metric, because C++17 brought in if const expr, and we could use that. It's not going to be a one-to-one mapping of whether or not concepts will be the adoption rate of concepts, but it is a spinne killer. People who have the ability to use it can get around copious amounts of spinne, and does that we can look at it and go, well, are people still choosing to support C++11, C++14, or are they sticking with C++17 and beyond because they have this thing that lets them get rid of a lot of programming nightmares?
I assume we'll see stuff first in the proprietary. We may see stuff talked about at conferences because somebody is going to show off a library that essentially we did this internally because we knew we were 17 or past, or more likely 20 or past. Because if we can say we're 20 or past, then you can start writing libraries that are concept-based libraries. And but I don't know how much pent-up demand there is for that. I mean, essentially the whole point of concepts is to make something that is widely usable. It's not something that you're likely to want to, we really want to do this proprietary library and concepts are going to unlock our ability to do that. No, really, the kinds of things you want to do are STL like things, wide variety of uses.
Yeah, you go on. I think you might be able to say what you might be going to say what I'm going to say. So please continue.
No. Actually, I was going to change the topic, and I was going to say that Connor is in the chat room, and he shared the link. ADSP.thepodcast.com is the correct link for what he's referring to as the one podcast to rule them all. So I guess he doesn't think the more the merrier. We may have to have a giant podcast, and we'll invite Connor and Anastasia and Bryce and Jason and Rob. We'll get everybody together and
a meta podcast
and the podcast to talk about podcasts. So anyway, what about other adoption of C++20 features in both in Clang and also in libc++? I haven't looked recently to see what kind of progress has been made against the standard. Are there other things that we should look at that are still to come?
Yes, there's still plenty to come. Something that I've moved into the ranges space now because concepts is all done. That was done to facilitate getting the ranges stuff in. So that's on its way, but there's nothing you can use yet. There's also some other work that's been happening. I believe there are a few compare things that are in flight, none of which have been merged yet. That's really all I know off the top of my head. I haven't spent a lot of time reviewing.
Did you say compare things?
Yeah, as in the spaceship operator.
Spaceship operator
stuff. Yeah.
Okay. All right.
Getting that sort of stuff in is pretty important because it really reduces the amount of boilerplate code that you've got to write. Now you don't have to write operator not equal to ever again from a library perspective. But if you also want to not write your comparison operators, you just want to say operator spaceship, we need to have a bit more library support for that. And then on top of that, there's a whole bunch of other things that the compare header also supports, such as a function object called three-way compare, or is it compare three-way? I forget what it's called. But essentially, it's like the function object equal to, where that uses the spaceship operator instead of the equality operator. And then there's a bunch of algorithms or dependencies for the spaceship operator's algorithms that that header needs to support, and I don't believe it supports currently. Then on the Clang side of things, the concepts library feature, so the concepts language feature still needs to have a few patches made to it for the changes that were introduced at the very last minute for C++ 20. I've sort of been beating the drum on that one a bit more because it's now starting to impact my my work in the library.
Ranges.
Yeah, it's actually, so I haven't technically confirmed this, but I've heard it mentioned a couple of times now on knowledgeable people that one of the reasons why Clang doesn't play well with libstd C++, GCC's standard library of implementation of ranges, is because we are lacking a few of the final parts of the language feature in the compiler. So that's something that I've been starting to get a little bit more loud about. There's also coroutines is something that I'd like to see implemented, finalized in its implementation. I've been told by someone who's very knowledgeable on the subject that they think that it's only a matter of like 1 or 2 patches that would make it go from TS mode into full C++ 20 mode. But I haven't had the time to investigate that
Because it's in now, but it's built against the TS instead of against the standard. Yeah. So they need to tweak the actual implementation. That's
basically my understanding. Yeah, you just need to say, hey, okay, so when the C++ 20 flag is turned on, now we want to talk about we want to be able to support coroutines, and then also it's no longer instead experimental; it's just in namespace std.
Oh, I see. Okay. So there's actually something you mentioned that, I don't know why I've never thought about this, but is LVM Clang using the GCC library? Is that a supported configuration that effort goes in to make certain that works?
So I can't speak for what the folks over at libstd C++, whether or not they prioritize Clang. I know that if you file a bug against it and it's something that they're willing to fix, then they'll fix it. But I don't know how much the priority is placed on that. I'll leave that kind of a statement to them. But yes, so the default library, the standard library that many systems build when using Clang is still GCC's standard library, and you need to opt into using. You need to opt into using the LLVM one. And that's just I think it's -stdlib equals lib C++ to opt into that. But if you're on a Mac, I believe it uses lib C++ by default. And there are a few other libraries, so a few other operating systems where it just does that by default.
I see. So for example, well, I was going to say, coming from the Mac world, I guess that's probably why I never really thought about it. But it's, if the compiler's clean, why not? You should be able to support any library. Well, so assuming the library is somewhat clean. But there are weird backdoors that are required. In other words, like traits and things like that, which are technically in the library, but they require special compiler support, right?
Yep. That's right.
Give me an example of where that's the case. Is it detecting unions, for example, or something like that?
So the trait is sane, for example, on LLVM has a built-in that we can use, and then on the GCC side, because lib C++ supports both GCC and Clang to a certain degree. Don't take that as an official statement, but we do have a CI branch for GCC, so I believe what happens is we use the compiler intrinsic for Clang, and for GCC we defer to just templates and rely on template specialization. For things that definitely require compiler support, I'm not exactly sure, but I think that that the folks would who work on the compiler would strive to try and get as little divergence as possible in the names. That way they work, And if that isn't the case, then you just have to have a set of if-defs. That way, it's if Clang do this thing, if GCC do this other thing, otherwise doesn't work.
Right. So I guess to clarify what I was talking about is most of the things that are in traits, you can write template code to determine that. It can be done entirely in the library. But there are some things, such as the only example that comes to mind right now is I think unions. There's no way you can call a template and pass in a union. You could have a vector of unions or something, but there's no way for you in library to figure out for certain that T is a union. So you need some way of asking the compiler, because obviously the compiler knows, is this thing a union? And the only interface to that, according to the standard, is to use the traits library. So if you're implementing the traits library, you're kind of screwed. So there has to be some backdoor way of telling the compiler, I need to know this. And obviously the standard library has to talk somewhere. So in other words, almost all of the standard library you could write yourself. You cannot do initializer lists because that requires special language support. And then some of the things in the traits libraries. And I assume there's other things, but I don't really, maybe you have ideas. I don't know what else you'd have to do. But almost everything, theoretically, wouldn't be much fun in most cases. It'd be kind of tedious. But you could, if you really, had your heart set on it. And I think for some things, like perhaps unordered map, it might actually be useful for you to write your own. so there might be some situations like that, but that's what I was wondering about. And so if you're going to mismatch, and maybe mismatch might even be somewhat disparative, but if you're going to have the GCC compiler and the lib C++ or vice versa, then it's just my curiosity of how we handle this. And what you're suggesting is it might be that the compiler intrinsics, the backdoors that they're using, might it be similar enough? Because, it's obvious the API flags that you pass the compilers are not it's not just a coincidence that those are the same.
Right, there's active effort that for those compiler flags between Clang and GCC, and I can say that with a teeny bit of authority because I've implemented a warning that in Clang that was specifically taken from the GCC interface to have similar sort of semantics. So that's definitely the case on at least on the front end side. Internally, I think the intrinsics are occasionally similar, and in the case where they're not, it's not that difficult to work out what the GCC intrinsic is if it's necessary, and just select which compiler you're on and choose it in that regard.
Are these intrinsics documented? I assume they must be, even though they're not in the standard. I assume.
I find out about them when someone tells me in a review, "Hey, why didn't you use this intrinsic?" But for the most part, the stuff that I work on, we want to keep it as rooted in library stuff as possible. So I haven't really touched many of the intrinsics at all. Sure.
Yeah, that's a back door. You don't want to avoid that if you can go through the front door. Of course. All right. Wow. That's a lot of stuff. So let's talk a little bit about, I alluded to the fact that you were, you'd fallen, what did I say? Fallen off the radar.
I think so.
I think a lot of people have fallen off the radar. I know a lot of people who normally speak at conferences. I've gotten some feedback from people who speak at conferences. Maybe Phil has gotten this as well from people who said, I don't want to do that again. Speaking at a virtual conference is a lot less fun because you aren't in the room with the people, and that kind of feedback is way more valuable than people think. You don't appreciate as a member of the audience how much the speaker is getting off of people nodding their heads or people looking puzzled or people laughing at stupid jokes. And for some of us, stupid jokes are really kind of important to our, we understand where we're going, and feeding off also the energy of the people in the room and the excitement and things like that. So I hope that
people laugh at your jokes.
It's been known to happen. It may be that I hear it as laughing. It's really groaning. I mean, that's entirely possible. In fact, that might be the most likely explanation, that I hear it as encouragement. Everybody else is hearing it as, oh no, did he just say that? C++ now is right around the corner. In fact, literally today, I hope to finish the schedule. We have the program, but one of the issues we have is that we have an awful lot of people at C++ now who are from Europe, and a lot of speakers from Europe. And this is actually, because we're doing it entirely online this year, this is an opportunity for people to speak at C++ Now or attend C++ Now that haven't been able to do so. And so they're sending us their schedule requirements, and it turns out that everybody wants to speak as early as possible. And that's going to be really hard to accommodate for everybody. So we're trying to figure out what we can do. But the schedule is very, very close to being released. And we do have, we have many of the speakers you've come to know and love, which is great. It makes C++ Now feel like C++ Now. But we have an awful lot of speakers we haven't heard from before or haven't attended before. And I'm just delighted that we're getting, C++ Now is an amazing conference, and but it's not always easy to get to. And so for those who, this may be the chance. And so that's what I was wondering about is, have you been able to attend conferences and speak, and are you planning to do so now more than?
Yeah. So I think so. I think I attended 1.5 conferences last year, and that was more than enough for me last year. This year I was on a panel earlier this year for diversity and inclusivity. That was a part of the Hash Include stuff with LLVM. If you're not a part of Hash Include C++, thoroughly recommend you join that community. And what was I going to say? Right.
Have you seen their T-shirts? Oh.
What was I going to say? Right. Yeah. So I've got one thing submitted to C++ on C at the moment. I've got 2 others that I want to submit to C++ on C, assuming the deadline hasn't passed. Phil?
Not yet. No, you've got cool. A few days.
Wonderful.
We should come back to that.
Sure. I think the key problem with those 2 ones that I haven't submitted is that I know what I want to do, what I want to talk about. I've got a really good roadmap of that, but getting the abstract out is the most difficult part. And John, you and I have a bit of a history here where I'll submit a thing to CPPCon. And then you'll have to come to me and say, Chris, this is a good idea, but this abstract just isn't going to work for anyone. Can you please go and
sometimes we always have the person whose talk it is writes the abstract. Who is a better authority? But sometimes in some situations that is the worst possible person to do it, because they are so wrapped up in the details and they see what's going on behind, and it's hard for them to think about it as, okay, what's the message you want to hear for someone who doesn't know all this stuff, who's not an expert in it. And so the abstract, we want to entice people, but we want to entice it in such a way that we're going to be able to deliver on whatever we're promising. So and it's tough. It's an art. It really is. Right. And some people are much better at it than others. And sometimes it depends on the particular subject matter. One of the things that I see people do a lot, and I understand it, completely makes sense, is they try to tell a story in the abstract. And, telling a story, that's really engaging and really gripping. But sometimes it's 2 or 3 paragraphs that tell us about how this feature was originally proposed here, and it was there, and then the committee did this in C++ 11, and they did this in 14. It's like, no, put that in the talk itself. That's a little background for the talk. But the abstract is, this is the feature, this is why it's important, and this is what you need to know about it, and that's what I'm going to deliver. And so anyway. Enough of how to write an abstract. But Phil, tell us more about what is the deadline and how are you doing? I know I'm envious. You get more submissions for your size of conference. It must be terrible for you, all the people you have to say no to, because you get a ton of good submissions.
Oh yeah, that's always the hardest part is saying no. But there's still plenty of room at the moment, so that the call for speakers is open officially for another 6 days. If you're watching this live, if you're watching the recording, it's probably already passed, but I'm going to try and get it out quickly. But I do want to go back to what you were saying a moment ago, John, about how a lot of people, speakers, regular speakers at conferences have been saying, yeah, I haven't done an online talk. I'm not sure I want to do that again. And it is different, and it is a bit harder and a bit more challenging particularly if you're an experienced speaker. That's the ironic thing. Like the more experienced you are, the harder you find it to make that transition. But it's a new thing. It also has some advantages as well, and we're still learning about some of those as a community. And you can be a part of that big experiment and discovering how to make excellent online talks. And some of those will even translate back to the regular conference talks as well when we get back to those.
Yeah.
So don't let that put you off submitting.
No, I wasn't
listen to John.
No, I wasn't trying to discourage people. I was trying to say this is an opportunity for people who, some of the experienced people are saying, I'm going to wait. It's not that much longer, another half year, and then we'll be back into the swing of things or something. Who knows? It's not a guarantee for me. But one of the things that I think, and we've seen a few people, I could mention names like Connor or David Sankel, who have made their talks. I think in the future, conferences will be about live talks and also essentially like a film festival, because people put so much work into making that talk pre-recorded, using great animation, cutting in maybe videos of other talks by other people. That's one of the things that Connor has done really well. And I do think, it's in a lot of ways, it is a lot easier to give that live talk when you're trying to prepare the canned talk. One of the things you do is every time you say something wrong, say, "Oh, let me do that again," and it ends up taking you like 6 weeks to get a 90-minute talk done, because you keep thinking, "Well, I could do that a little better," and you keep tweaking it. Whereas if you do it live, even if it's not 100% great, you're done. But also, there's a lot of energy to it too. When you're just speaking to a camera, that's hard to do, and in a live room, it's great. But some people, as I said, have taken this as an opportunity to say, "Look, if I can make a video of it, then why don't I do?" I mean, watch Jason's C++ Weekly, the way he's able to show off code and then actually does things. He actually writes the code, but he speeds it all up. You actually see him creating things. You see the typos he puts in and then fixes. I think that's what we're going to see in the future, is that conferences are going to do more and more. Again, I don't think that the traditional, hour-long lecture with Q&A, that's not going away. I don't want it to go away. I think that's great. But certain individuals are going to take it upon themselves to say, "Oh, I have an idea, and this particular idea, I could do animation and show you, what's going on with the register flow, and what are the elements in this container, and they get moved over here as opposed to copied over here, and you can animate that stuff, and people will understand it better." And it's a lot more work, but I think some people are going to be really delighted by the results. So I think that the future of conferences is going to be enhanced by the fact that we took a year and didn't do it live, because I think that and also, I don't know what your plan is for C++ on C, but for CPPCon, our plan going forward is to be a hybrid conference forever. And I don't think we ever would have done that if it hadn't been for COVID. But the conference last year was so successful that we've decided we want, and particularly, that's part of CPCon's mission, is to be kind of a platform for everybody to talk. And you can't very well say, "Well, we're going to platform for everybody to talk as long as those people can come to Denver." That doesn't make sense. And so, we do feel like there's something special about being on site and meeting people and getting to know people. And so that's what we're going to do, is we will have that live, but we will also have a hybrid experience, so people can attend and also speak, even if they can't attend. And I don't know how it's going to work out yet, because we've done live and we've done online. We've never done a hybrid before. So this year will be our first hybrid. And I'm starting to get excited about what the potential is. Anyway, like I say, I don't know. Have you decided what your future is as far as that? Are you going to do hybrids in the future, or are you going to go back to doing live when you can? Or
We are definitely looking towards doing hybrid in the future, but exactly what form that takes, we're still evolving how we're running these things, even the fully online ones. We're going to be trying a few different things this year as well, and I know you are too. So we're all in this together, working out what the best way forward is, I think.
yeah.
Talking of which, just one more point on that while I've got the mic.
Yeah.
C++ on C this year is also going to be a bit of a different format. Again, because we have done so much of the online conferencing over the last year, we're shifting a little bit more of the emphasis towards workshops, or as you call them, classes. So more like training events, which have usually been more of an add-on to a conference, and not everyone joins in with those. We wanted to make that a bit more of the focus. So there's 2 days of those, including half-day sessions. So if you're not something you've really tried before, it's a great opportunity, both as an attendee and as a speaker, a presenter, to try that out and see what it's like. And there are many advantages to doing training online that haven't really been considered before all of this happened. So that's what we're going to try and do this year. And we need people to submit classes. So if you hear this in time, go to cpp.chat.uk.
Yeah, I think that
your ideas.
I think that we've never had classes at C++ now, but CPPCon has had classes every since I think the second year on. We did classes, and I know Chris has done them for us, and they are. I think that people who don't do classes, I understand. I mean, the conference is 5 days. Add another 2 days on. That's asking a lot. That's very very demanding. But the people who attend them, I think, get a lot more out of the conference than those who don't. And so I'm a big believer in them, and that's why, we've thought about, it would be so much easier to just run the conference as a 5-day event. But now that we've offered the classes, we won't, because that is so valuable to those people who attend, and they get so much out of it. It is a different experience than a, traditional hour talk with a little bit of Q&A. And I'm sure Chris would say the class is a lot more difficult to put together when you're talking about the exercises, and it's a lot easier to dazzle somebody for an hour. If you're actually going to talk to them for an entire day and set up exercises for them and stuff like that, you got to fully know what you're talking about. So I hope you get the best of luck with attendance, both people wanting to do classes and also people wanting to attend classes, because I think that's really an overlooked source of value, and I don't think that people appreciate that enough. But and I know that people don't appreciate how much work it is. But I also and I know from my experience, because having gone through COVID, where basically for a long period of time there, I didn't do any training at all. It wasn't entirely my choice. It was mostly that clients that had set up to do training are saying, "Oh, whoa, we're cancel all our classes," right? In the last, what has it been? Not quite 6 months, I've been doing an amazing amount of online training, and I think there's potential there. It is not as good as on site, and I'm not going to back away from that, but there are things that can make that work. And there are actually, and the biggest thing for my clients is that a lot of them have people who are located remotely, and that makes classes available for them that really wouldn't have happened otherwise. And so
I can attest to that as well, because COVID hit. It's a pandemic, so everyone's been affected by it everywhere. John, as you know, Phil, I'm not sure if you know, and most viewers probably don't know, I used to teach at a university as well. And when I moved to Scotland, I petitioned to lecture remotely for the C++ class, and the response was, "Look, we prefer to have someone on site." When COVID came around, they came to me and said, "Look, we know you're interested in this. Would you be interested in being a co-lecturer? And so I jumped at it. I jumped at the chance and said, look, just donate the money to charity, and I'll put the time in. And then I found that was much more rewarding than trying to prepare things as pre-recorded stuff, because it's live, as you said. It's out there. I've said it. Can't take it back. And also you got this. It was on Zoom, so it's got this sidebar that's really small, but questions still pop up, and it's got a teeny bit of interactivity, whereas pre-recorded stuff doesn't. But it's still, so it's better than, in my opinion, a pre-recorded thing, but nowhere near as good as the live stuff. But it still works and is very accessible, and I think that's one of the biggest advantages of having this online training. And you talked about hybrid stuff in one direction. Like the conferences, it works in both directions. You can present to people at the conference once you get through the technical difficulties, and you can present to people at home. I think that's very easily made bi-directional. I think that the training, making hybrid training would be an interesting challenge as well. I don't know if you should pick it up in the same year, but I think it'd be something that'd be worth exploring once you've got the conference aspect down, because that would mean that you don't have to be on site for the training anymore either.
So, I mean, we shouldn't. we're getting close to out of time. I want to say this though. It depends on what you mean by hybrid. I have, last year at CPPCon last year, which is entirely virtual, we had online classes, and I don't think we'll ever have a single class that is both on site and online. All my training, and I have done that, because I've had clients who said, we want you to be here on site, and by the way, we have 2 or 3 people who are going to call in, and that is completely not the same experience for them. As an instructor, it's just, and I told the client, I said, okay, I'm going to teach the people in the class. The people online can ask questions. I'm happy to talk to them or whatever, but I'm not going to be looking to see if they understand the way I look at the people, here. And so I don't really see much of a future for having a particular class that's offered in both modes. However, having a class that's offered in one mode or the other, that may have a future. I don't think this year we're looking for that for CPPCon, but I can imagine a situation where, and it may even be the same class. In other words, we may have like a pre-conference class that somebody does on site and they offer it post-conference online. And I think that we might see things like that. One of the things that we realized about the classes was, because what we did for CPPCon is, instead of having them on the weekend, we actually just had them all the week before. Or, well, I guess some were the week before and some were the week after. Because, when you're traveling to that's why classes actually evolved at conferences, because you had to travel there anyway. Let's just extend it a little bit. But when you're doing it online, coming back a week later, that's not, I'm not getting on an airplane. I don't have to make, telephone or hotel reservations or anything like that. So that kind of changes things. In fact, we actually at one point were talking about, CPPCon, which is in October this year, but it's normally in September. We were talking about, what if we had in the springtime, we had maybe a mini mester. In other words, it's not a conference. It's training only, but we're going to have, a dozen training classes or maybe whatever. We talked about that. I don't know that we're going to do that, but anyway, that was one of the things, because, and that would be maybe our hybrid training. In other words, we do on-site training in September and then do the online training, kind of 6 months later or 6 months early, depending on how you look at it. Not certain we'll do that, but that's one of the approaches that we decided on. Anyway, I think we're kind of out of time here.
Yes.
But it's been great. Thanks for joining us, Chris.
Thanks for having me. It's been a lot of fun.
Thanks for coming.
So yes, and for those of you who are listening live, you definitely want to submit for C++ on C and register, even if you're not listening live, depends on when we get out, but register for C++ now. It's shaping up to be a great conference. I got so many things I'm really excited about announcing the schedule once we figure out what that's going to be. So did you have anything else we needed to say, Phil?
I think we can leave it till next time.
Okay. All right. That sounds great. So I'm going to ask Chris to join us in wishing everybody safe coding. So for everybody, safe coding.
Safe coding.
Safe coding.